This is Mike, your Chief Computer Science Engineer here at the Home Supercomputing Research Center. I'd like to welcome you back. We'll be working on Lesson 2 today of Apple Silicon Raspberry Pi ARM64 assembly language programming. We'll be putting together and demonstrating how to code an integer array, a simple data structure in ARM64. And I typically demonstrate these. You followed the first example. I demonstrate these on both the Raspberry Pi and the Mac OS. My goal in all of this, as we're learning, was to initially just to flat out develop on the Mac and Apple Silica, but I ran some caveats and some issues. So if you have books that are on Raspberry Pi by Stephen Smith, or the other one I had by Maria Markstetter, and you're learning ARM64 there are some strange caveats on Mac OS I ran into and that were kind of pulling my hair out of. And don't be surprised, we're going to run into one of those idiosyncrasies on the Mac OS today. And for that very reason, I'm going to start the tutorial on the Raspberry Pi. So we're going to see how we're taught to do it in the programming books that are out there, ARM64 by Stephen Smith and by Maria Markstetter in ARM Assembly, Eternals, and Reverse Engineering. Let's kind of dive into this. We're going to be building upon the first demonstration, the debug example.s we did previously in the first example, because we wrote a for loop for I equals 0, I is less than 6, I plus plus. And if you look at the screen right here, we're going to take it one step further. We are going to examine array elements in an integer array, and we're going to implement an integer array in ARM assembly language that will work both on Mac OS, on the Apple Silica, and both on Raspberry Pi. So let's dive in. I copied over verbatim example 1. If you guys remember seeing this from last time, there is our for loop, and I stuck in the array element. That's what we're going to implement. Of course, some of the stuff still has the structures here from the previous time. If you recognize our old for loop, this is it right here. So we're going to expand upon the first lesson and loop through elements in an integer array. So to do this, we're going to go ahead and jump out of our Visual Studio Code here on Raspberry Pi, and we're going to jump into CodeBlocks. We're going to create a new project, console application. We're going to use the framework for the C++. C or C++ works. We just need to grab that stuff to build our projects. And this guy will be integer array example. Where are we going to create that? We're going to create that in folder here. This will do nicely. Open there. Next. We want all that. Just take it all. Grab it all. And of course, it builds us a dummy project file, and we have the main.cpp. We don't need that yet. But let's file open our source code, which we had back in ARM64, integer array.s. This is one we looked at in Visual Studio Code. I want to open this. And then we would like to add it to the project. And files. That guy. And we're there. And so far, except for my comments here, these are verbatim because we're going to build upon the debug example.s we did last time. So the source code's verbatim right here. See this? There it is there. For loop. Let's just see what we got. Does it run? Make sure we don't got any issues. Build and run. We gotta get rid of our main. Remember that? Here we go. It does not like that other main being there. Let's delete that. See, there's a learning. There's a learning example there. Remove file from project. Be done with you. Yep. Let's do a build and run again. It's good. We have no segment errors. It just did the for loop like we intended. Now we can add to this. Let's add to this guy. What we need first, we're going to need an integer array. And let's do that down here at the bottom. Let's add a data section where our data will be at, down underneath the return and all that good stuff here. Do a dot data. That's where our array is going to exist. We want to align it on the 4 because we're going to be using Word. Line 4. And let's create our integer array. Int array. I'm going to call it a pointer. That's all right. Maybe a misnomenclature there, but it's pretty much what it is. Word. Let's just add some integers. 3, 7, 5, 2. That's not 2, 2. Or 8. Do we have 6 integers there? Yes, we do. That is it, guys. That's just how we create an array. We create a data section because we're using word size, right? 4 bytes, aligned by 4. So how do we access the array? How do we get to it? We're going to have to come up here. And before we jump into the loop, we're going to have to load the register, LDR. And we use this for giggles here, X19. And we use an equal sign, int. See the label? intArrayPtr. Now, according to the Holy Scrolls of Programming with 64-bit Assembly Language by Stephen Smith, this is the way we assign it. This is the way we do it. And the reading assignment is to go look at chapter 5, page 116 of his book, where he talks about how to do the load register. He's using a whole Hello World example, but it'll fill in the blanks on what I'm doing here because I'm also doing it with an integer instead of using ASCII. So that's it. X19 is going to be the pointer register to the address here, right? We can set this up. That's why I call it a pointer. X19 contains the first address, the pointer address of int array pointer. Okay, now what do we do with this? What do we do with this? We've got to access the array. Remember our for loop for I equals 0, and we jump down here into the loop, compare 32-bit register, W20 with W0. We're gonna initialize it to 0 there. Then we're gonna compare it to 6, because we only have 6 elements in the array. Compare W20 with 6. And if we get 6, branch out of here to the label down here, done. It's right there. So what do we add in here? We want to start looking and examining array elements right about here. So we need to copy whatever element from the address that's pointed by X19 into our 32-bit register here. Just by doing this. So what do we got here? Copy the contents at address X19 is containing right now in this register. Copy that data from this address into W1. So we're dereferencing. We're doing it, right? Let's just say copy element. X19. Boy, it's fun doing this live, isn't it? I just want to see so you guys can type in and just go with me, so it doesn't matter if I screw up or not. It gives you time to jump. Copy element. That's at the address of X19. So we're dereferencing, right? So W1 is now getting information from int array pointer. If we're looking at like the C language, right? That's what's happening here. And so we got to go to next I. This is good. We need this, but we also need to advance our pointer now. So how do we do this? We do add X19. How much are we going to be incrementing this by? How much will we increment this by? What's the biggie here? Remember, we were 4-byte alignment. So we got a line by 4. So we got to increment by 4. Let's just kind of say this is X19 equals, the address in X19 now equals int array pointer plus plus, right? We're looking at the next element. We're going to look at the next element. And I think we've got it here, guys. I think we've got it. Save. Make sure we don't get any segment errors. Oh, we're good. So what do we do now? What you gonna do now? We don't have a print statement yet. We will. We're going to get that the next assignment. The next lesson, we're going to add a print statement to this. We're slowly building this stuff, but there's all sorts of little things, caveats we got to catch right now before we move on. Let's look at this. So this should work fine. I'll look at CPU registers. I am interested in, what is it? We got X19 and W20 and W1. That's what we're interested in, right? We should see the loop going like last time. So let's step in. Boom. Yes. My console back. CPU registers. So what are we looking at here? We're jumping into load address X20. Have we done this yet? X19 2744. We haven't executed that yet. We see that move. Let's go to this. So we're going to step one more time. So you see we're at right here. We're now dropping into load register X19 with the initial address, the initial pointer address of our int array. Boom. We get it? Yep. Look at the bottom down here. This is our address. This is where our array is stored. Let's step in again. Now we should see what in W20 or X20 should be 0. It says 1 right now. We should see that become 0. What's our expectations? We're going to get it? We're going to get it? Yep, it's 0. And our address is still the same. Compare W20 with 6. Is it 6? Nope, it's not 6. Going to done? Nope, we're going to now dereference the array. We have X19 with the address of the first element. Now we're going to load register W1 with the first element from the array. See it right there? LDR W1 with whatever's pointed at by X19. So that should be what, our 3? Let's see what happens here. Come on, W1. Do we get a 3 in there? There it is. Look at it. We got the 3. We got the 3. Remember, the W is a 32-bit register of the 64-bit X1. So that's why we're seeing this. So we're monitoring the right one. So we should see X20 increment to 1 now. Right? Why is that? Add, right? There's a better way of doing these guys, these different referencing, but I'm not doing it here. I'm keeping it simple because a lot of us are just hobbyists and we're just learning. We don't have the PhDs, right? We're not there. I want the light bulb to go on and this be like, oh yeah, I know how to do this now. This makes sense. So we're keeping it simple. Keep it simple, stupid. So we expect W20 register to increment by 1 as we step. Let's hit the step button up here. What we got? We got a 1 in there, looking good. Now we're going to increment the X19 buffer. The X19 pointer. So we're down here. So we have 6160. We should be seeing 6164, correct? Let's see if my math is correct here. Bam, see it? 6164. Why? Because we incremented it by 4. And now we go here and we branch back to loop. We do it again. Boom. It's kind of cool. We're debugging in real time here. We're looking at the registers. We're going through our integer array. Like I said, the next time on, we're going to use a C runtime printf and print items out. But it's so much easier if you're debugging to get all the components that aren't using the stack or hopping to different processes. It's easier to look at a debugger like this, where it's just plain and simple. So what am I looking at here, Mike? Are we at W20? Are we at 6? No, we are not at 6, right? We are not. So we're going to step again. We're not at 6, so we go to load the next address. X19 into W1. What was our next one? Should be seen as 7, right? 7 should be showing up in W1. There it is. There it is. Very nice. And again, we increment our pointer, so we should be seeing down here, this should be changing to 6168 as we increment at this step right here. Let's see what happens. Boom, became 2. Okay, that's right, because we skipped a step. We're adding. Now, that's right, we're at 2 now. Second element, boom, and 6168. Cool, let's just keep going through this then. The next address, it's X, what's in W1? It should be what? We should be seeing a 5 appear in W1 now, in X1. It's 5, there it is, you see it? All right, playing with fire now. Makes sense, there, incremented by 4. And what is in our W20 registers 3. We're not ready to be done yet. So we're after the 2 should appear now. We dereference it. Here we go. Is it 2? There it's 2. See it? Became 2. Oh, love it when the plan comes together, right? We're not done yet. Branch back. Getting the idea, guys? Woohoo! What's our counter at? Our counter is at W20. We're at 5. Okay, we should be seeing something now. We're at 5. Let's follow it along. We're not done yet. Going to load the last element, which is what? 8. See the 8 down here? See 8? Hope this helps you guys with the light bulb to go on. I know it's tedious, but there we go. There we go. And we're at 6. Last one. It branched to done. It jumped out, right? It compared to jump to done. And that should kick us out. We're done. We're done. Awesome. Now this is working. We see this is working. What we're going to do now is we will jump back over to Mac OS and we're going to learn why we need to pull our hair out. Because I don't know, we're after Steve Jobs. What happened? Steve, ever since you're gone, they've been doing some crazy stuff. We're going to see how they dereference the array using assembly language, and it's slightly different and it's not obvious. So let's hop on over there. Okay, I've swapped back over to my Apple Mac Studio M2 Max system, and we now have the Raspberry Pi code loaded up. And kind of what we learned last time, except for the global main, the program starting addresses, the linkers, the Mac OS and Raspbian Link OS, this for loop worked perfectly. And it does work perfectly here. However, when we start dereferencing the array right here, we're going to run into some problems. Let me demonstrate to you what that looks like. Let's do a file save. So as you can see, I have the Raspberry Pi software loaded up here on my Mac M2 Studio Max here. And it looks identical. And just like the original previous example of debug example.s, this is the same code like we loaded up on the Raspberry Pi 5. And we know the for loop works. It works perfectly on both machines, unedited and swapped out. So now we went back, like from our last example, we put it into our int array pointer. And we have the load register X19 intArrayPtr. That looks good, right? Looks good, just like we had last time. Now we're going to run into the caveats of the apple here. Here we go. Apple, apple, apple. What'd you do to us? Drop down here. Do an L minus L. Make sure we have the current thing we're working with. Yes, we are. 1035 and print working directory. And we are good. So let's go ahead and compile this thing. Excuse me, let's assemble it. We're actually using a compiler to assemble it. But let's do a GCC minus G, create the debug. intArray, Command C, Command V. All right, so far so good. Whoops. What happened? Absolute addressing is not allowed in ARM64 code, but used in done referencing an array pointer map. So it didn't like this guy. Didn't like it. What is going on? What is going on here? It came from the sacred scrolls of Stephen Smith. He told us how to do this. What on earth? Well, we're going to have to go to the other temple of Apple here and check out what's going on here. Here we are. I have it up on the screen here. So look at this. This is from a Google search I did on this. So Apple Silicon ADRP at page. This is the preferred way. You know what? It doesn't even show up in their Apple's CPU documentation on best practices for this. This doesn't show up in there. They talk about the way Stephen Smith did. So this is interesting. I have no clue where this came from, except I had to pull my hair out and dig, and bam, there this thing is. So we're not using load register. We're using the ADRP instruction in Apple Silicon, ARM64, loads the page-aligned address to a 4K boundary, which is what we're doing, true, of a symbol relative to the instruction pointer within a 4 GB range. What is symbol relative? So our label here is the init pointer array. If you'll see down here, we're going to have to use their example. And that's how we're going to have to load it. So following their example, we're going to have to do something else too. What if we want this to run on both machines? We got to babysit Apple here. Here we go. We're back to here. We're going to have to take our conditional compiles, let's see, and build another little bridge here for Apple. We're going to drop down here because we're going to have an else. We're going to fill in the blanks. Else. And we'll get rid of that space. And then over here, we're going to have an end if. So we got to fill in the blanks just like we're instructed. What was that again? It looks like this. We need to implement that. Let's go back to this. We need to implement this right here. That guy. So what does this look like according to ours? So we are using the X19 register. Let's fill in the blanks here. So what was the command? It was ADRP, right? ADRP X19. No equal sign. Int array pointer at the page boundary, right? At page. The 32 bits. And then it did this crazy offset into the page. So we need an add. X19, comma, register X19, comma, and then the offset. So I believe this is all being done by the linker, right, to post an at page off using their. Did we get it? Did we get it? Let's see so far. So this is for Apple. If defined Apple and our Apple processor or Apple Silica, we're doing this. Else, if we're back on a Linux machine like a Raspberry Pi or something that's an ARM64 Linux, use the way sacred scrolls of programming 64-bit ARM assembly language told us to do it. Let's do a check-in here. So look right, ADRP. We have X19, comma, symbol at page. Load the base register of the page. And then we have right underneath it, right? We look good. We look good. Let's go back. And add the offset. That's where we're at right here. So far, so good. What else do we need? Is that it? Can we get away with this? I think that might be it. Are we good to go? What could possibly go wrong? Right, let's save this. What could possibly go wrong? We can just ship it. If it only has one fatal crash bug, we can ship it, right? Just like video games. Have people pay $50 and get the beta version. Oh, I have it local. Yeah, there we go. Come on, let's compile. Oh my goodness, we made it. We made it. Here was the initial error before that we corrected. We made it through here. Lord have mercy. Let's just see if it runs. Make sure we don't get any segment errors. So a ./8. We're gonna fix the linkers and stuff later. I'm just keeping this stuff simple for you guys. This is enough if you're just learning assembly language code to go through this. Like I said, I filled in a lot of blanks last time too, what we're doing. So these are progressively difficult little programs that you guys can walk with learning assembly language or feeling like you can do it. All right, let's fire this thing in the hole. Bam! It worked. We have no segmentation faults. Let's drop into LLDB. Let's drop into this thing. I have the extractions up here. So LLDB A.out. We good? Hey. Ooh, let's set our brakes. Minus name. Underscore main or main? Main. Let's give it a run. All right. Look at the ending array pointer. It's up there. Look at that. You see that? Very nice. We got it there. Okay. All right. So we got to do now. We got to send a breakpoint. We have to do a break set for the for loop. Name for loop. Boom. Then we'll do a continue. Look where we're at. Okay, cool. Cool. So what registers do we want to look at? We want to read registers. Let's see. We want to know what's in W20. W1, we have our data. Let's look at X19. Oh, look at that. See, it's even array pointer. It's telling us about this. So let's do continue. Where are we at in this? We're going to compare. Right. So W shard equals 0. Or no, it doesn't. Not yet. W20, yep. W20 is 0. Yeah, didn't have my caffeine in me yet. Let's go. Boy, oh boy. And read registers. Where are we at? Cool. Cool, cool, cool. Looking good. So we picked up our for loop I equals 1. The first array element equals 3. And we're at 8004. What do we expect to happen now? Let's go. Let's do this. Read registers. We're at 2. We picked up array element 7. Let's look at this thing down here. There it is right there. Pick up 7. It's going good. I think we got it. I think we got this thing. We mastered this thing. It took me over a month figuring this stupid thing out because I didn't know what to Google on. Like, what's going on here? I threw it out to Reddit and they didn't know, and it was crazy. It was crazy. lo and behold, you stumble upon something and you spit out your Diet Dr. Pepper and you're ready, like, that's what I'm after. That's what I'm after right there. What the heck? How'd that just show up? I'm not sure, but I think even Grok AI had it wrong. I'll have to go back and look. Because I was asked them too, and they're like, it still wouldn't do it. It's like, what the heck is going on? It's going. We have the 2, see? Counter's 5, we're at 4. We have one more element left. So W20 should be 6, W1 should be 8 in our next iteration. And memory address should be 8018 if we're doing our math correctly. Look, it's even telling us the pointer plus 20 now. The offset, that's flipping amazing. I'm loving it. I'm loving it. So you guys getting the feel for debugging, right? That's the important part of this. Boom. There it is. And we should just bail out of this thing now. It's done. It stopped. Quit. Seen enough? Good job, guys. Good job. We did it. So that's the difference here. Next time, we're going to visit the exact same code, and we're going to add a C runtime printf. So instead of going to the debugger, we're going to just print out values to the screen, which would be kind of nice things to have. So we need to know, we kind of got our feel now how to play around with the debugger and get into it, both GDB on the Raspberry Pi and both the LLDB on the Mac OS. So we're gonna get our feel. We're gonna do some more, a little more advanced stuff here. There's a lot of stuff I just wanted to play around with in my mind, and I thought this was a good way to document it. Well, I was learning the Apple Silicon. So you get it? So it's all the books we have on ARM64 are all written for Raspberry Pi. It's why I kind of coded side by side to figure out stuff. And I was using the Raspberry Pi debugger for the GDB built into CodeBlocks to help me figure stuff out. But when you hit stuff like this, it's just, even in the Apple Silica CPU optimization guide that talked about this stuff, it totally skipped that documentation on ADRP, the symbol at page and then add Xn, symbol at page off. There, it wasn't in there. It was not, because I plowed through that stupid thing. So if you guys know where it's documented or know where it's in the bowels of Apple, that's the absolute documentation. Feel free to comment in the field section below here on YouTube or on Rumble. But yeah, we'll be doing more difficult stuff here. I want to build do a printf, and then I've been playing around with multi-dimensional arrays, kind of like a build a little array. Like I've been watching the machine learning thing from, was it Harvard or something, one of the CSCs, and they computer science courses there. And they had a simple array that was doing pattern searching through, I think it was like a 10 by 10 array. So I want to start playing with that stuff too, playing with allocating memory, playing with little, simple binary trees or something to do, pattern searching out. Can we do a simple bubble sort? I want to keep the project simple and build upon. So when you jump on these, you get it. Like you do one after the other, go, okay, I have my skill sets built up enough. So that is the goal here at the Home Supercomputing Research Center with myself, Mike, your chief super science computer science engineer here. And yeah, let's have some fun with this. Let's bring the fun back to coding. Did you all see Network Chuck being dismayed about all the AI stuff just flooding out of the sewer spigot right now? He was overwhelmed. And I use some AI, and I use it sometimes. I've tried using it either to fix this, like even AI did not know about the Apple Silicon issue with ADRP. It probably will now. Now that I publish this, it'll probably, YouTube or Facebook will scrape this and go, hey, we have an answer to this now. We'll put it on Grok or whatever they're using, their LM, whatever it is. So anyhow, that's it. Stay tuned. Give me your comments of stuff you'd like to see done. I'm keeping it gradual. We're going to build up some bigger stuff. My whole thing was I came back years ago as a game developer. I worked for Activision back in the 80s. And I eventually sold out, went to Chips and Technologies to work on motherboards and the 386 chipsets. So I've been working with different various assembly languages, from the 6502, the 65816, the 68000. I've worked with PDP-11s, Craze, all sorts of crazy stuff. So I love assembly language, and I love going deep. I really want to start getting into is how do we hack in these AI chips, start playing with them, right? I want to get into Apple, the AI section of Apple. And Raspberry Pi came out with an AI Silica 2 that you can attach to your Raspberry Pi 5. So let me know, and just as we get our feet wet and we get understandings for stuff, let's just keep it basic. And we're gonna do it here, guys. All right. Until next time, we'll be working with the printf. Have fun. Enjoy coding.